The demonstration that we just did illustrates a principle called projectile motion. A projectile, firstly, is an object that moves through the air under the influence of gravity. So technically, if I drop this board marker, it's a projectile. But because it experiences gravity. Typically, when we talk about a projectile, we're talking about a projectile that's launched like this and flies through the air horizontally and vertically. If you've taken Math 20, you may know this already. The path that the projectile takes is called a parabola. How many people have done parabolas in math class? Hey, you know what a parabola looks like, right? Parabola looks like this. Well, if you flip that over, it looks like this. If I kick a football or throw a baseball up like this, you can imagine that it's going to take this path, a parabola. If you haven't taken Math 20, if you're just taking Math 20 right now and you haven't done that yet, just trust me. That's the path of the particle. It's called a parabola. Now, the horizontal component of that motion is constant motion or constant velocity. There's no reason for the horizontal motion to change. There's no reason for it to speed up or slow down horizontally. In the absence of air resistance, there are no forces acting. So, if the horizontal component is constant velocity, what equation do you think we'd use to describe it? You know this, yeah? It's group A, right? It's group A, or in other words, V is equal to delta D over delta T. That will always be the equation that we use to describe the horizontal velocity. Always. Because it's constant velocity. Now, the vertical component, or the y component, I guess I got ahead of myself there. I wrote down the equation before I uncovered that next piece of notes there. That's okay. The vertical component is acceleration. So what equation or equations do you think I could use to describe the vertical component? Well, Jacob kind of nailed it here already when he gave me the constant velocity equation. He said group A. Well, what am I going to do for the vertical component? Group B, because it's accelerated motion. You guys know all the group B equations, right? A is equal to delta V over delta T. VF squared is equal to VI squared plus 2AD. D is equal to VIT plus 1 half AT squared. All of those group B equations are valid, but the one that I'm typically going to use, even though they're all valid, the one that I'm typically going to use, and I'll say especially, is D is equal to VIT plus 1 half AT squared. So all of the group B ones are valid, but this is the one that's going to work for us the vast majority of time, so that's the one I'm going to write down first. Let's do an example here. And this example is from your book, page 107. Notice it says example 2.10, so that's going to be from chapter 2 if you're downloading these chapters of the textbook from our Google Classroom. You can do that, or of course you can snap photos of this or whatever. If you want the physical textbook, go to the library and grab it. Okay, question 2.10 on page 107 says, Head Smashed In Buffalo Jump near Fort Macleod, Alberta is a UNESCO World Heritage Site. How many people have been there to Head Smashed In Buffalo Jump? Okay, good. It's kind of neat, actually. So what happens is, like 6,000 years ago, the Blackfoot people of the plains hunted the North American bison by gathering herds and directing them over cliffs 20 meters tall or high. So what this amounted to is, look, you got these bison who are not known to be the smartest animals in the world, and you got these Blackfoot people that are much, much smarter and pretty ingenious, actually. Okay? Lack of technology, but some sense, okay, in their heads here. Says, look, we want to get these buffalo. We want to use, or these bison. We want to use their hides to stay warm. We want to use the meat to get fed. So what are we going to do? Well, the easiest way of hunting these buffalo is to trick them into running over a cliff. They all fall over a cliff, fall 20 meters, and then they all die. And then we harvest the meat and we harvest the fur. It's ingenious. It's simple, but it's ingenious. We say, assuming the plane was flat, so the bison ran horizontally off the cliff, and the bison were moving at their maximum speed of 18 meters per second, which is pretty quick, right? Faster than you or I can run. Determine how far from the base of the cliff the bison landed. So if you got a cliff here, and you got these bison running towards the cliff, we'll make this bison happy because he has no idea what's coming up. Goes off the edge of the cliff. Like, where does he land? We got to make sure that there's nobody standing down there at the bottom, because otherwise, if there's somebody standing down there, well, then that makes us no smarter than the bison. Okay? These Blackfoot people were a lot smarter than the bison, so they know where this bison is going to land. Not that they're necessarily doing projectile motion questions, but they know where the bison are going to land. What's the shape of this path called? It's a parabola. You see that if I extend that, it looks like a parabola, right? This is like a half a parabola, but we still call it a parabola. Always draw the picture. Always draw the picture. Okay, we're going to say that this bison is running off the edge of the cliff at 18 meters per second. We're going to say the cliff is 20 meters high. And we're going to say that we're looking for this distance right here. How far from the edge of the cliff does the bison land? Does that diagram make sense? I always say write down your givens, right? This takes care of it. Okay, drawing your picture takes care of the givens. That's the way you should write down your givens in these problems, is to draw that picture, because otherwise you're going to get confused between x and y without a picture. So what do I do next? You know what the nice thing about these problems is? You always start the same way, and then you just plug in numbers. And something just works out. It always happens. So here's the way I start. Number one, draw your picture. Number two, separate it into x and y components. Number three, write down the equations that I told you to use for x. V is equal to delta d over delta t for x because it's constant velocity, and d is equal to vit plus 1/2 at squared for the y component because it's accelerated motion. Always start this way. Always draw your picture and then write down your x and y components and the equations that go with that. Then, like I said a minute ago, sub in numbers and see what happens. You don't even really have a strategy now. It's brute force. Brute force. Sub in numbers, see what happens. Okay, let's start subbing in some numbers here. Do we know what the x velocity is here? Do we? What is it? 18. Well, how do we know that's x, not y? Yeah? Yeah, because the bison is running horizontally. The bison isn't running up a ladder like this. Okay? I don't know if you've ever seen a bison run up a ladder. Okay, they're not very good at it. Okay, the bison is running horizontally like this. And the bison isn't even running up at an angle, like up a hill like this, right? The bison is running horizontally off the edge of a cliff. So that horizontal velocity is 18 meters per second. Do we know the horizontal displacement? No, that's what we're looking for, right? We're looking for how far horizontally from the base of the cliff this bison landed. So we're saying that we don't know what that is. Do we know how long that bison is in the air for? Nope, we don't. All right, that wasn't very helpful. That's okay. That's okay. Remember we said it's brute force at this point. Just sub in numbers and see what happens. Nothing happened right here. If you're lucky, something will happen. If you're lucky, you'll get a number out of this. We didn't? That's okay. What do you think comes next? It's still brute force. We're not done yet. Try to do the other one. You get two equations written down. Now try the other one. If the first one works for you, great. If it doesn't work for you, then that's fine. Go to the next one. Do we know the vertical displacement here? This one right here. Yes, what is it? No, it's not 20. It's negative 20. Because the bison don't end up 20 meters above where they started, right? The bison end up 20 meters below where they started. Do we know what VI is? What is it? Right. Correct. It's 0. Why is it 0? How fast are these bison running up? They're not running up. They're running across. They're running horizontally, right? This initial velocity of 18 meters per second is all horizontal, and none of it is vertical. So we're going to say it's 0 plus 1/2 of negative 9.81, because that's the vertical acceleration, right? That's how fast the bison will fall vertically, or will accelerate vertically, times t squared. Now this looks a little bit ugly over here, but the good news is there's only one variable, t, and we can solve for that. But let's simplify it first. I get negative 20 equals 1/2 times neg 9.81 is neg 4.905. And you could do that on your calculator. Right? You could do that on your calculator and figure that out. Get rid of what's not attached. Well, there's nothing not attached. Get rid of what is attached. 4.905. How do you take it over to the other side? Demi, how do you do that? Sorry? Division, right. It's multiplied by t squared. I see a negative in front of it, which makes sometimes we think that it's going to be add. Okay, but we're not subtracting that from t squared. We're multiplying it by t squared, so we take it over by dividing. It becomes negative 20 divided by neg 4.905 equals t squared. And that gives me 4.0775. And then I'm going to find t by square rooting that, right? Square root that, and we get 2.019. We solved for something. It's great. How long is the bison in the air for? Before it hits the ground? 2.019 seconds. It's not what we're looking for, though. That's okay. Remember the strategy? Draw the picture, write down the equations, and then brute force. Okay, you don't have to, like, if you're doing brute force, you can't go wrong as long as you sub things incorrectly. Okay, I haven't made a mistake here. I solved for something I'm not looking for, but that's okay. Now I have an extra given. Where do you think I'm going to use that time? Am I going to use it? Rachel, where am I going to use it? Yeah. Look, the time that it stays in the air vertically is the same as the time that it stays in the air horizontally. So now I want to sub that in there. Say 18 is equal to delta D over 2.019. And then I take the 2.019 out by multiplying. 2.019 times 18 gives me 36. What was I looking for again? The horizontal displacement, right? How far it goes horizontally. What did I just find? The horizontal displacement. How far away from the base of the cliff the bison ends up. Yep.
Should you round? When should you round?
You should round and your final answer. So this 2.019 is not a final answer for time, so we do not round. I mean, we have to round somewhere, right? Because like it may be 25 digits. We're not going to write down 25 digits. 4 or 5 digits is usually fine.
Well, because if we're doing significant figures.
Yeah, well, but you don't round to significant figures until your final answer. And your final answer should have 2 digits. This is 3. It should have 3 digits, shouldn't it? Final answer should have 3 digits, so that should be 36, not 36, but 36.3 meters. So, what's the strategy? Draw the picture, write down the 2 equations, the same 2 equations every time, and then brute force. Sub in the numbers, get something. If it's what you're looking for, great, you're done. If it's not, then keep going. Keep going with your brute force until you get something. Hey, quick question for you. The velocity, you can see here, for x is different than the velocity for y. I can't use them interchangeably. Why is it that I can use the time interchangeably for x and y? Why is it that Doesn't really matter x or y for time, but it does for velocity. There's a quick, simple answer to this question. You guys all know it. Because time's a scalar. There's no direction with time, right? So x, y, whatever. Velocity is a vector. So the velocity is going to be different for x than it is for y. Right? Okay, what I'd like you to do then here is to take a look at these 3 questions on page 107 of your textbook. Feel free to snap a photo of this or just look at it on the board.